Next is the quadratic functions. What are quadratic functions, or what is a quadratic function? A function f is a quadratic function if f of x is equal to ax squared plus bx plus c, where a is not equal to 0 and a, b, and c are all real numbers. Take note, the condition a is not equal to 0 here is not a restriction so that the function does not exist. It's a restriction so that the function is quadratic, because if a is equal to 0, the function is bx plus c, which is a linear function. The graph of the quadratic function is called a parabola. Also, the domain of a quadratic function is the set of all real numbers. How about the range? The range of a quadratic function can be determined by transforming the function ax squared plus bx plus c into f of x is equal to a times the quantity of x minus h squared plus k, where h and k are also real numbers. So since it is a parabola, the form of the graph is either opening upward or opening downward. If the parabola is opening to the right or opening to the left, that is not a function. This is not a function. These two are not functions. So we will be dealing with the parabola which is either opens upward or opens downward. So later on we will know the importance of transforming this equation here, f of x is equal to ax squared plus bx plus c, into f of x is equal to a times x minus h squared plus k. But first, let us try to graph the basic parabola. F of x is equal to x squared. Question: is this a quadratic function? No? Are you sure, guys? Take note that this x squared here can be written as 1x squared plus 0x plus 0, meaning our a is 1, our b is 0, and our c is 0, and 1 and 0 are real numbers. So therefore, that is a parabola. Okay, so how to graph this one? We will try to do it by creating tables so that we will know some ordered pairs in the parabola. So first, let's create table. This is our x, this is our f of x. Okay, suppose our x is 0. What is our f of x? That's 0 squared, that's 0. Now if x is 1, our f of x is 1 squared, which is 1. If x is 2, our f of x is 2 squared, that's 4. Now if x is negative 1, our f of x is negative 1 squared, that is 1. Then if our x is negative 2, our f of x is negative 2 squared, that is 4. So we have ordered pairs here: 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. So we can draw now the rectangular coordinate system. So we have 0, 0, then we have 1, 1, 1, 1, then we have 2, 4, 2, 3, 4 here. Okay, this is 0, 0, This is 1, 1. This is 2, 4. Then negative 1, 1. We have negative 1, 1. That's negative 1, 1. Then we have negative 2, 4 here. Negative 2, 4. Then connect the points. Okay. Okay. So this is our f of x is equal to x squared. So this point here is called the vertex of the parabola. Vertex of the parabola. In that case, our vertex is the origin of the rectangular coordinate system. Now, what will happen if our f of x is negative x squared? Is this a quadratic function? Yes, our a is negative 1, then our b is 0, and our c is 0. So what is the form of the graph of this function? So we have, again, let's do tabular form first, x, and then f of x. If our x is 0, our f of x is 0. If our x is 1, our f of x is negative 1. Then if our x is 2, our f of x is negative 4. If our x is negative 1, our f of x is negative 1. And if our x is negative 2, our f of x is negative 4. So if we graph this one, okay, again we have 0, 0 point here. Then when x is 1, this is negative 1. That's 1, negative 1. When x is 2, that's negative 4, negative 2, negative 4. When x is negative 1, that's negative 1, negative 1, negative 1. When x is 2, that's negative 2, negative 4. Then connect the points. Okay. So this is our f of x equals negative x squared. And in this case, this is our vertex. Again, our vertex there is the origin 0, 0. How about if f of x is not x squared or negative x squared? Example, if we have f of x is equal to 2x squared minus 8x plus 4. How do we graph this one? Well, we can also do tabular style, tabular method, what we have just did on x squared and negative x squared. However, it might look messy because you have to substitute over and over again. So if we encounter functions in this form, ax squared plus bx plus c, again, as what I mentioned a while ago, we can determine the range and even the domain if we transform that function in this form. Okay, this is very helpful in graphing quadratic functions. By the way, before we do that, let's find first the domain of the first two examples. In f of x equals x squared, the domain is all real numbers. Again, remember, the domain of the quadratic function is the set of all real numbers. The domain is all real numbers. How about the range in our first example? So the range, again, just look at the y-axis. So the range is from this point of origin, the 0 to positive infinity. Then 0 is included. So that is our range. How about the second one? In the second one, again, the domain is the set of all real numbers. And the range is, okay, 0 to negative infinity. Now it should be from negative infinity to 0, where 0 is included. So there. How about this one? Okay, so what we want to do here is we transform this one into f of x is equal to a times x minus h squared plus k. Okay, so meaning we can do that if we apply the completing the square method. Okay, we apply the completing the square method. Okay, we have discussed last time about completing the square, how to do completing the square. And also, I believe it was already discussed in your previous math, even in your senior high school or maybe junior high school. So how do we do that? First, group the terms with the variable. So you can group 2x squared minus 8x plus 4. Then factor out whatever the coefficient of x squared. So the coefficient of x squared there is 2. So you can factor out 2 so that we have x squared minus 4x plus 4. And then that's the time you do the completing the square. Okay? Remember, this is a square. That x minus h squared there can be written as x squared minus 2hx plus h squared. So what we lack here is the perfect square. How do we do that? Again, computing the square. How do we do computing the square? Get the half of the coefficient of x, which is negative 4. The half of that is negative 2. Then square it. So what is the square of negative 2? That's 4. Then add it in the parenthesis, inside the parenthesis. So negative 4x plus 4. Then to make the equation still correct, you have to add another value here, which is the negative of the product of this value here, the one that we added, and the coefficient of the parenthesis, of the term inside the parenthesis. Okay, so that's 2 times 4, that's negative 8. 2 times 4, that's 8. Then get the negative of that, so that we add negative 8 here. Why? Because we are just simply adding 0 there, so that we are not violating the mathematical rules or the equations there. It's just adding 0. It's just adding 8 and negative 8. So now we can express this x squared minus 4x plus 4 as x minus 2. That is a perfect trinomial squared. Then 4 minus 8, that's negative 4. So in this case, this is already in the form of f of x is equal to a times x minus h squared plus k. So here we have our a is 2, our h is 2, and our k is negative 4. Okay. Now it is very important. Why? The hk there, this hk is our vertex. That is the vertex of the parabola. So therefore, we already have now a vertex which is 2, negative 4. So if we graph this one, we can just locate that 2, negative 4. We have 1, 2, 1, 2, 3, 4. Okay, that's 2, negative 4. Now, if a, so we have two cases here. If a is greater than 0, then the parabola opens upward. Okay, the parabola opens upward. Now, if a is less than 0, the parabola opens downward. In this case, our a is 2. So therefore, we have an idea now that this graph here opens upward. So next is just identify some arbitrary points. Arbitrary points near our h. Near our h, so that we can have other ordered pairs in the graph. So find arbitrary points near h, meaning it is from the left of h and from the right of h. Okay, one point from the right of h and one value from the right of h and one value from the left of h is enough. So our h here is 2, so we can have the right is, let's say, 3, then our f of x. Meaning, when x is 3, what is our f of x? So f of x is equal to 2 times 3 squared minus 8 times 3 plus 4. So that's 2 times 9 minus 24 plus 4. That's 18 minus 24 plus 4. So that means our f of x when x is 3 is minus 2. Okay, that's correct. Is it minus 2? Yes, that's negative 2. So we have an ordered pair here, 3, negative 2. So 3, we have this one, 3, negative 2. Then, from the left of h, which is, let's say, take 1. So f of 1 is 2 times 1 squared minus 8 times 1 plus 4. That's 2 minus 8 plus 4. That's negative 2. So therefore, here is negative 2. So we have an ordered pair which is 1, negative 2 here. That's 1, negative 2. Then you can just connect the points. You can have this function. This function is f of x is equal to 2x squared minus 8x plus 4. So in graphing, we have, again, consider these steps. Step 1, find the vertex of the graph. Find the vertex of the graph. And you can find it from f of x is equal to a times x minus h squared plus k, because our vertex is hk. Next, take arbitrary values of x. Take arbitrary values of x from the right and left of h, equidistant. Okay, and solve for f of x, and solve for f of x to get the ordered pair, to get the ordered pairs. And then after that one, after having the vertex and two ordered pairs, additional ordered pairs, connect the points. Connect the points to identify the graph. Now, what can you observe about this graph? But before that, let's identify first the domain. Again, the domain is all real numbers. How about the range? The range is from this point here, up to the positive infinity. What is that point of y-axis there? That's right, that's -4 to positive infinity. So what can you observe? One is the one we mentioned a while ago. A identifies whether the parabola opens upward or open downward. So if A is greater than 0, the parabola opens upward. If A is less than 0, on the other hand, the parabola opens downward. Also, the vertex of the parabola is the minimum or maximum point of the graph. The vertex HK of the parabola is the minimum or maximum point of the graph. Okay, it is the minimum if A is greater than 0, and it is the maximum if A is less than 0. Okay, again, when it opens upward, that's the minimum. When it opens downward, that's the maximum. Okay, that's right, the parabola is symmetric from x equals h. Okay, the parabola is symmetric through x equals h. So in this case, our h is, in the first example, our h is 0, so it is symmetric on the y-axis. Same with the second example, but in the third example, it is symmetric. So there's line of symmetry here. It is symmetric through x equals 2. Okay, so that line here is called the line of the parabola. X equals h is called the axis of the parabola, or line of symmetry. The range of the parabola, or the range of the quadratic function, is negative infinity to k if A is less than 0 and k to positive infinity if A is greater than 0. See, the transformation of the function to f of x is equal to a times x minus h squared plus k is very important, because from that alone we will be able to identify the vertex. We will be able to identify the line of symmetry or the axis of parabola. We will be able to identify the range, whether it is negative infinity to k or from k to positive infinity. Okay, so that transformation is very important. Question so far? Now, if you are not comfortable with the completing the square method in transforming the function or the equation, and if you find it a bit messy, you can also find the value of h and k in this case. So the vertex, the h and the k, can also be determined by solving this formula. H is equal to negative b over 2a, and k is f of h. So from our example a while ago, our f of x is equal to 2x squared minus 8x plus 4. Again, our a is 2, our b is negative 8, and our c is 4. So solve for h first. Negative b, which is negative 8, and our 2 times our a is 2, which is 8 over 4 equals 2. Next, solve for k. K is f of 2, and f of 2 is 2 times 2 squared minus 8 times 2 plus 4. So that is 2 times 4 minus 16 plus 4. That's 8 minus 16 plus 4. That's negative 4. So therefore, we have h, k, which is 2, negative 4. And this is what we got from our completing the square. From our completing the square. Where is it? Here. Okay, here. 2, negative 4. So it's up to you if you use the completing the square or you use this simple formula in finding our vertex or finding the value of h or value of k. Questions? Okay, we have practice problems. Try to graph this one and find the domain and range of the following quadratic functions. Negative 4x squared plus 4x minus 3, g of x is equal to negative 2x squared plus 10x plus 5, h of x is equal to 10 minus 3x plus x squared, t of x is equal to 5x squared plus 10x minus 1. Okay.